in 13.1. So let's just look at an example from yesterday dealing with spherical coordinates. If we have x squared plus y squared equals z, I think we looked at this one in yesterday, potentially. But I just want to rewrite this. This is rectangular coordinates, or like you said, Cartesian coordinates. The question is, what would this be in spherical coordinates? How can we rewrite it using our formulas? Well, we had some formulas yesterday given to us from the representations of spherical coordinates. And if you remember, the equations we had were x equals rho sine phi cosine theta, and then y is rho sine phi sine theta, and we have z equals rho cosine phi, right? And then we had, so obviously that one's pretty easy to just plug in right here, correct? And then we also had, and I asked you both, you could verify that, just square this out. X squared plus y squared plus z squared is actually going to equal rho squared. So we get a really nice identity formula here. So, if we're looking at x squared plus y squared, we can utilize this and say, hey, this equals rho squared minus z squared. Do you agree? Just subtract z squared from both sides. And so I can write rho squared minus z squared equals z. And then I could also, whoops, that's my one of my reminder alarms. All right, so anyway, I can rewrite this as rho squared minus z, putting in z, I can plug it in there, here, and here, right? And so it's rho cosine phi quantity squared, and then equals rho cosine phi. If I do that, I should have done that back in blue, but that's all right. Anyway, so this is rho squared minus rho squared cosine squared phi equals rho cosine phi, right? And then if I do this, I can factor out a rho squared, right? If I factor out a rho squared, I'm left with 1 minus cosine squared phi, and that equals rho cosine phi. Now, what can I replace 1 minus cosine squared phi with?
I'm guessing either rho or theta.
No.
Wait. What sine squared phi?
Yes. So I can replace that with sine squared phi.
Yeah.
So I'm gonna clear this, so I got room to move. That's the only problem with, not the only problem. I got a lot of problems with this software. What? Clear annotations and they don't go away. What's up with that, Isaac? Because I got my eraser on. That's why.
I don't know.
Well, so it should let me erase, but it's not letting me erase very well. So I'm just gonna clear the whole thing. Hopefully. Oh my goodness. Drawing. It's locked up again. I don't understand how this locks up on me. So I'm going to let you finish this, cancel out the rows, and then see what you get, and then try and use trig to simplify it a little bit and solve this for row. So I'm going to let you do that while I go out and come back in. But I want final answer rho equal. Rho squared times sine squared phi equals rho cosine phi. Of course, the one row would cancel, right? So I've got rho, and then if I divide both sides by sine squared phi, I've got cosine phi over sine squared phi equals rho.
That's what I got.
Right? Now, but that's, we could rewrite this a little bit different. So if I wanted to rewrite this as cosine phi over sine phi times 1 over sine phi. So that's probably not going to be the answer in the back of the book because they're going to do this. What could I rewrite cosine phi over sine phi as?
Inverse tangent.
Not inverse tangent. Not inverse tangent, but
cotangent.
cotangent.
That's sorry, cotangent.
Cotangent. Yep. So this is cotangent phi times 1 over sine is secant, right? No, cosecant. 1 over sine is cosecant. Gee whiz. Cosecant. So it's cotangent phi, cosecant phi, or vice versa, cosecant phi, cotangent phi, either one. So anyway, this is probably the answer that they would have for that. Okay. And that's taking, this rectangular coordinates, rewriting in spherical. So if we had a potential graph, if they said, hey, graph rho equals cotangent phi, cosecant phi in spherical coordinates, we'd be like, oh man, that's going to be a chore to try and figure out what that looks like. But we could go the other way, get back to this, and then all of a sudden, I think that was the right circular paraboloid sitting on top of the origin, right? So that we did yesterday, because if z equals 0, it's the origin. If z equals 4, it's a circle. If z equals 9, it's a circle of radius 3, right? If z is negative, it doesn't exist. So we did that one yesterday, and the graph, I believe, sat on the origin and was a right circular paraboloid, right? Looked like that. So anyway, all right, now moving on.